Okay, we're going on to chapter 7 now, and I've got some data up. And the first topic we're going to talk about is interpolation. You have pairs of XY data right here. And you want to know, well, what if X is this? What do we expect Y to be? There's a function for this. Forecast. Now, again, Excel has a lot of different options. Linear is probably what you want. For a seasonality, confidence interval, exponential smoothing, all those other things, all these other things, you can figure out when you're later. We can't learn everything about Excel right now. Let's just stick with simple linear. This one's also simple linear. You'll notice the little yellow triangle down here. It means Microsoft is going to get rid of it. They're going to replace it with forecast.linear. I don't know why they do that. They make things more complicated. Okay. And it tells you when you select forecast.linear, it says, what is the X value? There it is. This is the X value. Comma. What are the known Y's? There we go, right there. Your functions a lot of times give you hints about how to use them. What are the known X's? There they are, right there. Boom. Now, 2.05. Let's go to 2.05. We expect it to be halfway between 5.5 and 7.2. And what is that? 8.5 plus 0.85 plus 5.5 is 6.35. We expect it to be 6.35. Let's check it. There it is. So that's your forecasting tool. And it allows you to interpolate between data. Now, extrapolation goes a lot further. Let me draw some things here. So interpolation is interpreting between two different points, a few points. It's inside. Interpolation is inside. Extrapolation is outside. So let me get the drawing tools. There we go. I'm going to draw something. So I'm going to draw your XY axis right here. Now, you have two data points. Interpolation is what is Y in the middle somewhere. Extrapolation, oops, this is a really lousy straight line. I don't have a straight edge for my computer. Okay. Is if X is this, what is the value of Y? The trouble is, the model, there's a lot of variation. When you try to extrapolate out, you're trying to hit the mark, but you don't know exactly. Let's see if I can do a better straight line. A better straight line would be more like this. So under a straight line would be like this. So anyway, there's this whole range of values that you could get when you try to extrapolate. I'm going to show you something. These are the COVID predictions. They're extrapolations. So up to here, we are current. Let's see, what's the date today? October, late October, somewhere around here. Anyway, this is what we've had so far. We've had a bump in July. Arizona had a similar bump. These are extrapolations up here. This is the purple area is the range, how far off the extrapolations can be. So the further you go out, when you try to extrapolate further, the more error, more range of error there is. Let's take a look at Arizona, where we're at. Of course, these videos were made during the height of the COVID crisis. I like to look at hospital resource use because it tells us if we have enough hospital capacity to treat everybody who comes in who's infected. And of course, it's going to be proportional to the amount in the population. It's also going to be proportional to severity. And the data is taking a little while to load up. I'm going to pause the video for just a second. Okay, here's Arizona's data. We are following a general trend that the United States is going through. I think December, January, February are going to be rough times, but they're not going to be as bad as last July. There's also a plot on mask use. Here's mask use. We're going to have a lot lower infections with universal mask use. This is the projection. The middle one is the current projection. And if we ease mandates, if we say, okay, let's not use masks anymore, let's not care, we're going to be on this line, the high line. I think we want to be on the low line. You risk a 1 out of, 1 out of 33 chance of death with COVID. There's a 0.1% chance of death with the ordinary flu, even without a vaccine. With COVID, it's 3%. 3%, yeah. So that's, take a 6-shooter, 5.5 of them, load one of those barrels with a bullet, and play Russian roulette. You get to pick from the table of those 6-shooters, and one of those chambers in one of those 6 is going to have a bullet in it. Do you want to play Russian roulette that way? I don't want to. So let's not play it. Let's wear our masks. Let's stay on the low side. Let's try to prevent it as much as we can. Okay, let's move on. Let's go back to some of the same data that we used for graphing. And let's take a look at that. Now we have some variation. It doesn't follow an exact straight line. This is the solvent concentration versus time, by the way. Let's add a chart element. You can do it over here, by the way, too. Let's see if I can make it show up. Oh, there it is, the plus sign. If I'm too close to the edge, let's click that closed. There. Click the chart. You can add a trend line from here, options and everything. Linear, let's do linear. There's the trend line. Right-click on the trend line and format it. You can get the equation this way. Display equation. Display R squared. So let's go back here, move this up, and let's see if we can make it a little bigger. They want to make it nice and small. I don't know why. Okay, so there's the equation of this line. What fitting does, here's what fitting does, is it looks at the difference between the data point and a line and takes the square of that, and takes the difference between the line and the data point and takes the square, and the line and the data point takes a square, and the line and the data point takes a square, and so forth, and adds up all the sums of squares of these deviations. Deviation from the line, deviation from the line, deviation from the line. It adds the sum of squares of all these deviations and then minimizes it. It's calculus. So I don't want you to worry about the exact math of it. I just want you to understand what the algorithm's doing. It's trying to minimize the sum of squares between the line and an individual data point. And this r squared is a measure of how close, how small that deviation is. If r squared is close to 1, then it's a small deviation. If r squared is close to 0, that means it's not very good. It's a large deviation. These deviations are pretty big. This one's kind of small, 0.98. That's really good. In the social sciences especially, you'll find that it's not nearly as good. Okay, so that's a straight line fit. And let me get my... Well, anyway, you can see the equation. Y equals mx plus b. You can see the equation right here. Now, we're going to look at what to do about other kinds of fits, things that are nonlinear. So that's the next topic in the next video.